Welcome back from the break. My name is Joel Hewlin, and I am a senior data engineer, cloud architect, and general manager of the training practice within Soliance. I've been in the industry for about 26 years, working in many different roles from desktop support to development. And over the past 5 or 6 years, focused more on big data and analytics within the cloud. In this module, we show how Azure Synapse Analytics enables you to perform data engineering tasks using the power of Apache Spark. In our sample customer scenario, Tailwind Traders has both unstructured and semi-structured files from various data sources. Their data engineers want to use their Spark expertise to explore, ingest, and transform these files. We'll show you how to address these challenges through Synapse notebooks, which are integrated in the Azure Synapse Analytics workspace and used from within Azure Synapse Studio. Let's get started with Module 3.
In this module, we're going to talk about performing data engineering with Azure Synapse Spark pools. Now, let's go over what data engineering means within Apache Spark pools in Azure Synapse Analytics. Let's set an agenda for today's meeting in which we are going to discuss the following: understanding big data engineering with Spark and Azure Synapse, ingesting data with Spark notebooks, transforming data with data frames in Spark, and integrate SQL and Spark pools all in Azure Synapse Analytics. Let's go over what Apache Spark pools are in Azure Synapse Analytics. Apache Spark is an open source memory optimized system for managing big data workloads, which is used when you want a Spark engine for big data processing or data science where you don't mind that there is no SLA provided. Usually, this is of interest to open source professionals, and the reason for Apache Spark is to overcome the limitations of what is known as SMP systems for big data workloads. The second option here, HD Insight, is an implementation by Microsoft of open source Spark managed on the Azure platform. You can use HD Insight for a Spark environment when you are aware of the benefits of Apache Spark in its OSS form, but you want an SLA. Usually this is of interest of open source professionals needing an SLA as well as data platform experts' experience with Microsoft. Azure Databricks is a managed Spark as a service proprietary solution that provides an end-to-end data engineering and data science platform as a solution. Azure Databricks is of interest for data engineers and data scientists working on big data projects daily because it provides the whole platform in which you have the ability to create and manage the big data and data science pipelines and projects all on one platform. Synapse Spark is a capability of Spark embedded in Azure Synapse Analytics, in which organizations that don't have existing Spark implementations yet give the functionality to spin up a Spark cluster to meet data engineering needs without the overhead of the other Spark platforms listed. Data engineers, data scientists, data platform experts, and data analysts can come together within Synapse Analytics, where the Spark cluster is spun up quickly to meet the needs. It provides scale in an efficient way for Spark clusters and integrates with the one-stop shop data warehousing platform of Synapse. Let's talk about Apache Spark history for a little bit. Apache Spark has its architectural foundation in the Resilient Distributed Dataset, or RDD, a read-only multiset of data items distributed over a cluster of machines that is maintained in a fault-tolerant way. Spark and its RDDs were developed in 2012 in response to limitations in the MapReduce cluster computing paradigm, which forces a particular linear data flow structure on distributed programs. MapReduce programs read input data from disk, map a function across the data, reduce the results of the map, and store reduction results on disk. Spark's RDDs function as a working set for distributed programs that offers a deliberately restricted form of distributed shared memory. Azure HD Insight is a Hadoop service offering hosted in Azure that enables clusters of managed Hadoop instances. Azure HD Insight deploys and provisions Apache Hadoop clusters in the cloud, providing a software framework designed to manage, analyze, and report on big data with high reliability and availability. Azure HD Insight uses the Hortonworks Data Platform, or HDP, Hadoop distribution. Databricks grew out of the AMP Lab project at University of California, Berkeley, that was involved in making Apache Spark, an open source distributed computing framework built atop Scala. Databricks develops a web-based platform for working with Spark that provides automated cluster management and IPython-style notebooks. Finally, Azure Synapse Spark, known as Spark Pools, is based on Apache Spark and provides tight integration with other Synapse services. Traditional Spark developers now have Spark Pools preloaded with Anaconda libraries, offering over 200 libraries for machine learning, data analysis, and visualization. It also comes with support for Delta Lake and integrations with Azure Active Directory, Data Lake Storage, and others. But what is Apache Spark? It is a parallel processing framework that supports in-memory processing to boost the performance of big data analytic applications. Apache Spark and Azure Synapse Analytics is one of Microsoft's implementations of Apache Spark in the cloud, as we saw in the previous slide. Azure Synapse makes it easy to create and configure a Spark pool in Azure. Spark pools in Azure Synapse are compatible with Azure Storage and Azure Data Lake Generation 2 storage, so you can use Azure Spark pools to process your data stored in Azure. There are several benefits of Spark pools. One is speed and efficiency. Spark instances start in approximately 2 minutes for fewer than 60 nodes and approximately 5 minutes for more than 60 nodes. The instance shuts down by default 5 minutes after the last job executed, unless it is kept alive by a notebook connection. The second benefit is ease of creation and use, including preloaded Anaconda libraries. You can create a new Spark pool in Azure Synapse in minutes using the Azure Portal, Azure PowerShell, or the Synapse Analytics.NET SDK. Synapse Analytics includes a custom notebook derived from Interact. You can use these notebooks for interactive data processing and visualization. Spark in Synapse Analytics includes Apache Livy, a REST API-based Spark job server to remotely submit and monitor jobs. Another benefit is support for ADLS Gen 2 or Azure Data Lake Storage Gen 2. Spark pools in Azure Synapse can use Azure Data Lake Storage Gen 2 as well as blob storage. Scalability. Apache Spark and Azure Synapse pools can have auto-scale enabled so that pools scale by adding or removing nodes as needed. Also, Spark pools can be shut down with no loss of data since all of the data is stored in Azure Storage or Data Lake Storage. Some of the concepts of Apache Spark and Synapse Analytics are Spark pools. A Spark pool is created in the Azure portal. It is the definition of a Spark pool that, when instantiated, is used to create a Spark instance that processes data. When a Spark pool is created, it exists only as metadata. No resources are consumed, running, or charged for. A Spark pool has a series of properties that control the characteristics of a Spark instance. These characteristics include, but are not limited to, the name, size, scaling behavior, and time to live. As there is no dollar or resource cost associated with creating Spark pools, any number can be created with any number of different configurations. Permissions can also be applied to Spark pools, allowing users only to have access to some but not others. A best practice is to create smaller Spark pools that may be used for development and debugging, and then larger ones for running production workloads. And Spark instances are created when you connect to a Spark pool, create a session, and run a job. As multiple users may have access to a single Spark pool, a Spark instance is created for each user that connects. When you submit a second job, then if there is capacity in the pool, the existing Spark instance also has capacity, then the existing instance will process the job. If not, and there is capacity at the pool level, then a new Spark instance will be created. For example, you create a Spark pool called SP2. It has autoscale enabled between 10 and 20 nodes. You submit a notebook job, J1, that uses 10 nodes. A Spark instance, SI1, is created to process the job. Now, you submit another job, J2, that uses 10 nodes. Because there's still capacity in the pool, the instance auto-grows to 20 nodes and processes J2. Let's go over how to ingest data with Apache Spark notebooks in Azure Synapse Analytics. Through the Develop Hub in the Synapse workspace, you can create notebooks. These notebooks can be written with multiple languages like PySpark and Spark SQL. In order to ingest data through notebooks, you can use a linked service from the workspace to, for example, an Azure Data Lake storage, which then the keys and access is automatically passed through the storage account where you have stored that file and you want to ingest and read out into a Spark data frame. You can access data in the primary storage account directly. There's no need to provide the secret keys. In Data Explorer in the Synapse workspace, right-click on a file and select New Notebook to see a new notebook with data extractor auto-generated. It is also possible to create your own data frame within Azure Synapse Analytics, running on a Spark pool within the Data Hub of Synapse workspaces. With data created on your own without a source specifically, you can load data from Azure Blob Storage or ADLS Gen 2 and SQL Pool. For example, you can ingest data into a Spark data frame by reading a CSV from an Azure Data Lake Storage Gen 2 as a Spark data frame. You can configure the Spark pool with a Spark session per notebook where you can specify when the session should time out, how many Spark executors you would like to use, as well as the size of the executors and the driver size. So you have the flexibility per Spark session to configure the compute resource that you would need on demand. You have the flexibility in scaling your notebook session, so scaling up and down between notebooks is possible. With the possibility to write in multiple languages and passing through of keys where data sets is stored, you're flexible in coding data engineering without switching tools. Let's put this into reality and show you how it works. In this demo, we show how Azure Synapse Analytics enables you to perform data engineering tasks using the power of Apache Spark, which we've talked about for a little bit. And what I want to do is demonstrate that in action. Tailwind Traders has both unstructured and semi-structured files from various data sources. Their data engineers want to use their Spark expertise to explore, ingest, and transform these files. You recommend using Synapse notebooks, which are integrated in the Azure Synapse Analytics workspace and used from within Synapse Studio. Tailwind Traders has Parquet files stored in their data lake. They want to know how they can quickly access the files and explore them using Apache Spark. You recommend using the Data Hub to view the Parquet files in the connected storage account. Then use the New Notebook context menu to create a new Synapse notebook that loads a Spark data frame with the contents of a selected Parquet file. So to start, on the left-hand side here, we see our different hubs that we can select. We choose the Data Hub, and we select Linked. And we can see different categories here. Because these files are stored in the data lake, I'm going to expand this and choose the primary data lake storage for this workspace. And the files that we're interested in are in the WWI02 container. When I select that on the right-hand side, I can navigate to the folder structure that I want. So let's open Cell Small, year 2010. And you can see here that the files are organized by year, by quarter, and by month. So if I choose quarter 4, month 12, and you can see that it's also organized by day. And doing this allows us to build more efficient queries to get to the files that we want. And here we can see the Parquet file. If you right-click on the file, this context menu shows you different actions that you can take. The ones that we're interested in are under New Notebook. And here we can load to a data frame or Spark table. So let's choose Load to Data Frame. Our first option here is to attach to an appropriate Spark pool. We have just one. We can manage the pools and add additional ones, maybe that have different configurations or different sizes and scaling. We can also choose the default language. We have Python, but we can choose Scala, C#, and Spark SQL, which is a T-SQL-like syntax. This just sets the default language, but you can choose a language at the cell level, as we see here, using what are called magics. It's the double % followed by the name of the language, in this case, PySpark. So even if the default language here was Spark, Scala, for instance, this cell would still execute using PySpark, which is Python. We see here that this is not started. The Spark pool has not started yet. And the Spark pool provides the compute for all notebook operations. And when we execute the first cell in this notebook, what'll happen when this pool is idle, the pool will start and allocate those resources. It's a one-time operation until the pool auto-pauses from being idle for so long. Now, before we run this, what I want to do is set a new variable because we're going to be writing or creating different cells, and we want to refer back to the name of the data lake account at one point. So let's call this data lake equals, and I will copy the name of the data lake account here. So we can refer to that later. We don't have to duplicate this name further down. So if I run all, this is just one option to execute the cells. You can execute them individually. You can execute all of them by hitting run all. And as you notice here, it says, please wait a few moments while your session starts. That's the Spark pool being started and the resources allocated. Okay, it took about 2 minutes for that Spark session to start. I cut out that time in the interest of time. You can see here that the cell is currently running. We could see the job execution has now succeeded. And by default, the cell output is to a table view when we use the display function. And if I hover over the display function, notice that we have some information about the function as far as the parameters that we can pass to it. And what we've done here in this cell is we're using the spark.read method to load the Parquet file. And because we right-clicked on the file in the Explorer, which is here, since we did that, when the notebook was generated for us, it added the path to that file directly. And what we're doing is we're loading that to a data frame. And if I hover over that, we could see that variable df is of type data frame. And this cell here, or this line here, is just saying display a df limit 10 records. And we could see those 10 records here in the table output. You also notice here that in view, there's a couple of options. If I select chart, now I could see a default chart visualization based off of that data. Now let's choose view options on the right. And we'll keep it as a bar chart. We could see the different chart types here in the list. But I want to change the key to product ID. And for the values, the total amount. Everything else is here is fine. We don't need the series group. Summing for the aggregation is fine. And if I select apply, now I could see the chart has changed. And if it's dynamic, if I hover over one, I could see the total amount for product ID of 64 is 281.52. Now we can create a new cell in a couple of ways. One is if I hover directly to the bottom of the cell, I could see add code or add text. With a notebook like this one, we can display information in a couple of ways. For instance, if you do add text, it allows you to add a markdown cell. So if you want to add a description or maybe instructions that you want to add to the notebook, you can do that by adding a text cell. Right now, I just want to add code. You could also add a new cell up here. Now, the Spark engine can analyze the Parquet files and infer the schema. And to do this, what we could do is add a command here, df, which is our data frame dot print, if I can type, print schema. Now, I can execute just this cell by hitting the little play button to the left, or I could do Control Enter to execute the cell and stay, but if I do Shift Enter, it executes the cell and creates a new one below it. And we could see in the output the inferred schema, and what that means is the Spark engine analyzes that Parquet file, and based on the data within the file, it takes a best guess as to those data types. As we can see here, the data type next to the name of the property, string, integer, short, byte, etc., whether it's nullable, in this case, they're all nullable. This automatic inference is usually sufficient for data exploration and most transformation tasks. However, when you load data to an external resource like a SQL table, sometimes you need to declare your own schema and apply that to the data set. But for now, the schema looks good for us. Now let's use the data frame to use aggregates and grouping operations to better understand the data. And I will paste some code in the cell to save some time. At the top, we import required Python libraries to use aggregation functions and types defined in the schema to successfully execute this query. Let me execute this real quick. Shift Enter again, executes and creates a new cell below. Okay, now let's look at the output here and compare that to what we put in the cell. We could see the aggregate functions used, such as sum, average, and sum. And it's within this ag method. So what we're doing is we're taking the data frame and we're grouping by two fields, transaction date and product ID. And then within ag, we are getting the sum of profit amount, and we're providing an alias. And you can see here the alias sum profit amount is what shows up in the header of the table here. So we provide aliases for each of these. And we could see the sum of the profit amount, the average quantity, and the sum of the quantity. And we order by the transaction date. And then display, we're creating a new data frame out of this original one with the aggregates, and we're displaying that and the first 100 records. Transforming data with data frames and Spark pools in Azure Synapse Analytics. Complex data types are increasingly common and represent a challenge for data engineers, as analyzing nested schema and arrays tend to include time-consuming and complex SQL queries. It can be difficult to rename or cast the nested columns data type. Performance issues arise when working with deeply nested objects. Data engineers need to understand how to efficiently process complex data types and make them easily accessible to everyone. In the following example, Synapse Spark is used to read and transform objects into a flat structure through data frames. Synapse SQL Serverless is used to query objects directly and return those results as a regular table. With Synapse Spark, it's easy to transform nested structures into columns and array elements into multiple rows. In the example, the steps show the techniques involved to deal with complex data types. Step 1 is to define a function for flattening. We define a function to flatten the nested schema. This function can be used without change. Step 2 is to flatten the nested schema. Use the function to flatten the nested schema of the data frame into a new data frame. In step 3, we explode arrays. Transform the array in the data frame into a new data frame. And finally, step 4, we flatten child nesta schema. Use the function to flatten the nested schema of the data frame into a new data frame. Now, if this was difficult for you to follow, you're in luck, because now we will show you in the demo how we put this into reality. Now let's talk about transforming data with data frames in Spark pools. What we'll do first is we'll query and transform JSON data. We worked with Parquet already, but we're working with JSON data in this case. So in addition to the sales data, Tailwind Traders has customer profile data from an e-commerce system that provides top product purchases for each visitor of the site or customer over the past 12 months. The data is stored within JSON files in the data lake, but they've struggled with ingesting, exploring, and transforming these JSON files, and they want your guidance. The files have a hierarchical structure that they want to flatten before loading into a relational data store. They also wish to apply grouping and aggregate operations as part of the data engineering process. To do that, we'll use, again, a Synapse notebook, where we can explore and apply data transformations on those JSON files. So let's go down to the new cell. I'll paste in this code here, where again, we're using spark.read. And this time we're defining an option where we're telling it we do want to infer a schema, and the type is JSON. And notice here in the path mostly matches what we saw above as far as using the ABFSS protocol, which is specifically for reading against our ADLS Gen 2 storage account. And again, it is within the container WWI02. But notice here that we are concatenating this value with our data lake variable that we put at the very top here, right? So that way we don't have to, again, copy and paste down here. And notice that the path here is we have this online user profiles 02, but we have star.json. So with this wildcard, we're able to say, give me all JSON files within this location. And this value multi-line equals true means that we have multiple values within the JSON files. And we want to get all of those. And then when we run this, we'll run print schema. So let me do that now. Okay, so here's the schema printed out in the output. Notice in the schema, a couple of things that are different. One is this hierarchical structure compared to what we saw with the Parquet file. We also have here that it's identified the fact that we have array values within. And we could see that even within the arrays, it did infer the data types for the different properties. We've been using Python code in these cells up to this point. If we want to query the files using SQL syntax, one option is to create a temporary view of the data within the data frame. To do that, execute the following code. df.create or replace temp view user profiles. What this does is it creates, again, a temporary view. In this case, we're providing the name user_profiles. When we create a view like this, we are able to access the data stored in that view from different languages within these cells. So for instance, if we want to use SQL, if we want to use Scala, we can access the data in that view using those languages. In this new cell, notice that we're using the %% magic. And this is, again, like I said at the beginning, this is how we define which language that we want to execute the cell in. One of the beautiful things about notebooks like this is that you can mix different languages within the same notebook. And below that, we could see a syntax here in our statement that is SQL syntax. If you're familiar with SQL syntax, you should be able to figure out what we're trying to do here pretty easily, where we're selecting all columns from this temporary view and only returning the first 10. Okay, notice that the output looks a little bit different. If we expand one of these, we could see now the nested structure. Let me make this a little bit wider. Okay, so we have here items purchased in the last 12 months. And then within that, we could see we have products that are listed with values. So we have this nested structure. However, this nested structure does make analyzing the data a bit difficult. Now that we've seen the fact that this is hierarchical, there is a structure that includes arrays. Remember, one of the things that Tailwind traders wanted to do was to flatten this data before importing it. PySpark contains a special function called explode. So first we're importing from PySpark.sql.functions the UDF